We are the paradoxical ape. Bipedal, naked, large-brained, long the master of fire, tools, and language, but still trying to understand ourselves. Aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. CARTA brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
Hi, I'm Reed Montague. I'm from Virginia Tech, from the Fralin Biomedical Research Institute, and I'm here to talk today about neural substrates of mindfulness. But before I get started, I just want to credit the motive force behind this, certainly in my lab and then with me over the last decade, and that's Ulrich Kirk, who's now at the University of Southern Denmark. Ulrich has had a long-term interest in mindfulness meditation, both as a practitioner and as a mode of gaining control over our cognitive functions. So as a neuroscientist, I'm quite interested in one that does imaging in humans. I'm quite interested in how that comes about, the neural systems that are involved, and how we might harness this and micromanage it in a way. So I just wanted to start by depicting what others, not me necessarily, define as mindfulness. And John Kabat-Zinn, you see in this quote here, it says, it's paying attention in a particular way, on purpose, in the present moment, and non-judgmentally. Now, there's a lot of ways into mindfulness meditation, none of which I can depict for you. I'm a computational neuroscientist that works in the area of neuroimaging and models that pertain to neuroimaging. And so I don't know how to make a comment on this kind of definition. But I do know how to think about cognitive control. So let me just say the way I see some of the aspects of mindfulness, and I think these are subtle problems. And that is something that we in the lab like to call the superpower. So there's something about humans that's obvious that sometimes goes overlooked, and that is we can interrupt our biological needs, our need to eat, to sleep, to excrete, flee, experience pain based on an idea, literally based on an idea. A person in a religion, a person in a group, a person can come to think anything they want to think, use that to gain control of everything they do, literally, to the extent that they can even kill themselves. This is a kind of behavioral superpower, and I think it's probably fair to say that if it's not unique to humans, it exists in a unique form in humans. Okay, so what? Well, the so what is, what are the neural systems involved in this? And can we start to tease apart brain responses and brain systems that have been identified that might impinge on this kind of superpower as I've described it here? So I'm going to focus today on two specific question types. The first is mindfulness practitioners. Are they better at regulating emotional states during social exchanges? And in this case, we're going to set up a staged social exchange, and we're going to ask, do people trained in mindfulness meditation, are they able to withstand fairness and unfairness better than people that aren't so trained? And secondly, does mindfulness impact the way valuation systems in your brain work? And in both cases, I'm going to ask very simple questions. That is, I'm going to do very simple experiments. So I don't want anybody to think that I'm making the statement that this somehow subsumes the whole of mindfulness. The measure of interest that we will use, the neural measure of interest, is functional MRI. And as you know, functional MRI is a proxy for small blood flow changes in the brain, and blood flow changes in the brain are highly correlated with neural activity changes. This is a workhorse method for people interested in cognitive neuroscience. So we will be putting people in scanners while they do various kinds of tasks. The treatment that we'll focus on is a treatment between control subjects and otherwise matched subjects that have either been trained in mindfulness or within a training paradigm in mindfulness meditation. Okay. To that end, we've been carrying out for about the last 10 years what we call the mindfulness task battery. And I'm not going to go through this. This is just to show that we have all kinds of little tasks that we have focused on. I'm going to focus on two that I've highlighted here in red. The first is a primary reward task. In this primary reward task, something simple is going to happen. And a rodent experimental psychologist would call this a simple passive conditioning task or a conditioning task. Light will come on. Sometime later, a squirt of fruit juice will be squirted into your mouth. And then we're going to manipulate the expected timing of the squirt of fruit juice. Okay, so that's a very basic primary reward task. The second kind of task, I'll draw your attention down here to the Ultimatum Game, is best described as a take it or leave it game. We're going to give someone an amount of money. They're called the proposer. They are going to propose a split across another person, the person being studied. In this particular case, you see it's a 9/11 split and a $20 handout. So person starts with $20, offers a split to the other person, and the other person accepts it and walks away with the money, or rejects it, in which case no one gets anything. So what that does is it sets up a tension between how you respond to an unfair offer and whether or not you should accept any non-zero offer. In economics, the rational choice agent would accept any non-zero offer in every offer, but that's not what people do. Okay? How did we do this? So I'm going to start with the Ultimatum Game. We did this by first carrying out a very, very long training paradigm that took, I suppose, 2 years for us to carry out these experiments. This is, again, driven by Ulrich Kirk. So we had a result some 8 years ago using this kind of game, and you see it depicted here at the bottom. The black player is the proposer, and the red player is the responder. The black player each round is endowed with some amount of money and offers, in this case, X to the other person. So in the case that I showed before, it was $20, and the offer was, I'll give you 9 and I'll keep 11. You then get to choose whether you accept and get the 9, or whether you reject because you don't like that split and no one gets anything. The fact is, people can get very incensed at what they consider to be an unfair offer. And that's what we're going to use to probe this. We're going to range from perfectly fair and equitable split across the two players to profoundly unequitable across the two players. And we're going to look at the brain responses. Before we do that, we're going to set up a giant randomized control design where people were recruited with very generic terms, not mentioning meditation or mindfulness at all. They were then randomly assigned what we call the mindfulness intervention group or the active control group. And here in my second bullet point, I call it the physical relaxation group. We hired trainers that were skilled in the art of teaching mindfulness meditation, and people came in on regular duty cycles every week, and we scanned them throughout the process of being naive to meditation and then being trained in meditation. So these are naive participants randomly selected into the training group or to the active control group. The active control group got relaxation instructions for the same amount of time the others did during the training paradigm. This is a published paper, but I'm just going to talk about a couple of the results in it. Okay? Remember how the Ultimatum Game works. So let me show you. On the x-axis here, we show the offer size. And on the y-axis, I'm showing the percentage acceptance rate. So when there's an exactly even split, 10 to me and 10 to the other person, the responder, which is the person that we're probing here, accepts almost all those offers. There's just a little noise there. That is, if I'm offered 10 and I know that $20 is being split, I accept literally all the time. As the offer size to me reduces from 10 to 9 to 8, and you see in the middle there, 15 to the proposer, 5 to me, the rejection rates go higher, the acceptance rates go lower. But the main thing is that the two groups, the group selected into the mindfulness intervention and the group selected into the active control are identical across all those offer size levels. And they both show the exact same tailing off as the offer size diminishes down to the miserable offer of 19 to the proposer, and I take $1 away. Now, a rational agent should take the dollar. Okay, that's not what people do. There's this response in them that, reacts to unfairness, and it's important to react to unfairness. After training, after 8 weeks of training and establishing that the mindfulness group is different in various ways, I showed you some of the tasks that we did on the mindfulness battery, and I'm now just discussing the one Ultimatum Game. You see that there's a separation starting at about 13 to 7, 14 to 6 splits across the two players, and the mindfulness group is accepting more and more inequitable offers as it comes. And frankly, with training, this gets to be more and more extreme. In other words, in a sense, they're accepting money that they didn't have before the offer, and at a rate much higher than people not otherwise trained. So there's the behavioral result. The neuroimaging result, there are many actually. I'm going to start by showing you what does a region of their brain that we know responds to negative affect, and this is the anterior insula. And I'm showing it here on the left. You're looking at a coronal section through the brain, through the average brain of, I guess in this particular case, 58 subjects. Left is left and right is right. And you're seeing an activation there, and I'm not going through the detailed statistics of any of this. I'm just hitting the high points. You see a strong activation in the anterior insula on the left side. You see a smaller one on the right side. That activation scales with the degree of unfairness, both in the control group, you see here in blue, and in the mindfulness training group, the group that's going to be given the mindfulness training paradigm. Percent signal change in the insula. Okay? What we found is that this response to increasing unfairness, this response in the mindfulness group got flatter and flatter as the training went on. And we discovered something else as well, that it wasn't just the response of the insula that was habituating as it was as a function of the mindfulness training. It was its connection to other regions of the brain known to be involved in valuation and in social exchange. One region shown here is the septal region, that's on the left, and you see here the interaction between the septal region and the left anterior insula. And I've plotted at the right here the correlation coefficient based on a particular kind of analysis between pre-training and post-training. Okay, so that's a social exchange game that's been studied by many others across many different cultures and many different circumstances. We've used it even to look at the differences between people that have traditionally defined psychopathologies and matched control samples. And what we saw here was control subjects randomly selected into the control arm and people trained in mindfulness. So we can induce this in naive people by doing the meditation training. I want to address one more feature, and that is, how does such training also affect what you would call low-level primary reward responses? Is it true that their mindfulness practitioners are sort of living in the present as it was? And the hypothesis is the decision-making mechanisms in the mindfulness people are seeing a relatively flat value function. By flat value function, I mean this. One of the ways we look at reward systems in the human brain is we see them as evaluating the next things that could be done. Evaluation functions, the way that the artificial neural networks evaluate board states now to play chess and Go and things like this. They have a value function that says, how valuable is it if I might move X and change the board to one condition versus move Y and change the board to another condition? Same thing here. And our hypothesis was that what these people end up training themselves to do is to have a relatively flat value function across all options. And I'll come back to this at the end because of I think the impact that this may have on Parkinson's disease. But the current state, in a sense, is equivalent to any other state. So we did a very simple experiment based on an experiment we did basically 20 years ago. Okay, a yellow light is turned on, left on for 1 second and extinguished. A 6-second delay, and we squirt fruit juice into your mouth while you're lying in a scanner. Okay, we do this a number of times. 20, 25 times, etc. And what happens is that your brain gets very used to the light predicting 6 seconds into the future a certain amount and quality of juice that's going to be squirting into your mouth. Then, after that training, we can then change the timing of the juice squirt, and we induce in your reward systems what are called reward prediction errors. And this is pretty easy to see here. The dashed red box indicates a time when a certain amount of juice was expected but not delivered. That would be a negative prediction error. Things are worse than you would have expected. And then the novel delivery time of juice at 10 seconds in the catch trial. So we have two kinds of errors there. Positive prediction error, where juice is delivered but not expected, and a negative prediction error, where a certain amount of juice was expected, nothing was given. That's a negative error. This just shows the number of trials that went into it. Let me draw your attention to the top of the slide here. There's the light going, being illuminated for 1 second. There's a 6-second delay. And now we're looking at the time when the juice is delivered at the novel time of 10 seconds. Okay? And it's being compared to the normal events where it's delivered at the 6-second delay. And when you do that and compare the brain response of meditators in our training paradigm here, in our 8-week, after our 8-week training paradigm, and the active controls, there's a profound difference. You can see this on the images between controls and meditators and positive prediction errors. And then when you contrast controls to meditator brain responses, you see this down at the bottom, both in the brain response and in the percentage signal change in the left putamen. So this is the putamen down at the lower left here. Again, we're looking at a coronal section through your brain, and you can see that on the catch trials, when the juice is delivered at a surprising time, the control brains in this region give a gigantic response compared to the meditators. And the meditators give no different response than they did to the normal time of juice delivery. What we think is happening is you're retraining your reaction by various means that we could speculate over in the discussion to the expectations that form. Here's the same thing for the response to negative errors. So this is the 6-second delay where the juice is expected, but nothing is delivered. Again, there's no response to this in the meditators. That's a negative reward prediction error. And there's a big and profound response to the controls. And you see in the lower right with the blue and red bars that the meditators show no difference across normal and catch trials, in the controls, so a big difference. Now, I have to say one thing that's a technical point, which is the non-response of the meditators to the negative prediction error is really a mute condition. We don't have in functional MRI a good estimate of the false negative rate. So we don't really know how to say anything to a brain that doesn't respond because we don't know what the level would have been and sort of anyway. Now, there's some ways around that, but there are not ways around that in this kind of design. So I think the thing to focus on is that there's a relative difference across the controls versus the meditators. Okay, well, so we've seen that while people bring very lush narratives and training paradigms into the idea of what mindfulness can do to you to help you concentrate, to help you calm down and be less stressed, to manage various aspects of disease states, that in fact they do induce changes that are measurable with functional MRI. And I'm just going to point to the future directions. The future directions from my lab are that we are now able to make direct recordings in conscious human brains of neuromodulatory systems that deliver chemicals like dopamine and serotonin and norepinephrine to widespread regions of the brain that we know are involved in setting and stabilizing certain kinds of brain states that we think are involved in this training that this training effect that we're seeing right here. And so that's the future direction here. It is direct recordings in human beings during opportunities afforded by neurosurgery for making such recordings and looking at the direct impact on neurotransmitter release profiles for meditation. So thanks very much for having me.